What is the link between factoring and polynomial graphs? Imagine trying to understand the shape of a curve just by looking at its equation. How do you know where it crosses the x-axis or how it behaves at those points? That's where factoring comes into play. When you factor a polynomial, you break it down into simpler parts called factors. These factors reveal the zeros or roots of the polynomial, which are the points where the graph touches or crosses the x-axis. For example, if you have a polynomial like x squared minus 3x minus 4, factoring it gives you x minus 4 times x plus 1. Setting each factor equal to 0 shows you the zeros are for and negative 1. These zeros tell you exactly where the graph hits the x-axis. Now, the way the graph behaves at each zero depends on the multiplicity, which is the exponent on each factor. If the zero has an odd multiplicity, like 1 or 3, the graph will cross the x-axis at that point. If the zero has an even multiplicity, like 2 or 4, the graph will just touch the x-axis and turn around without crossing. This helps you sketch the shape of the graph near each zero. Factoring also helps you write the polynomial in a form that makes graphing easier. If you see the zeros and their multiplicities, you can draw the graph more accurately. The degree of the polynomial and the leading coefficient, which is the number multiplying the highest power of x, influence how the graph behaves as x gets very large or very small. This is called the end behavior. So, in simple terms, factoring a polynomial is like finding the key points on the graph. It shows you where the graph intersects the x-axis and how it behaves there. Without factoring, you would need more complicated methods or technology to find these points. Knowing how to factor helps you understand the shape of the graph and makes sketching it much easier. It's a fundamental step in connecting the algebraic form of a polynomial with its visual appearance on the coordinate plane.